Hello people, I'm Salman from ANTT Robotics and welcome to the second episode of IoT Hacks presented to you by School of IoT and powered by ANTT Robotics. Though, in this episode, we are going to do something a bit more fun rather than turning some LEDs on and off. And also we are going to see what it can do and what's its application. So let's start with today's topic, and it's controlling your fan/AC, whatever you have, using the power of the internet, or as known as School of IoT. So it's an IoT-based fan and AC control system. Fan or AC control system depends on what you have. So to make this whole thing happen, to demonstrate this whole thing, we're going to need this few things. Well, yes, it's a few things, not a lot of things. Don't worry with that. So we are going to need this DC motor. It's a DC motor with a propeller attached to it. We are going to just kind of represent the AC or fan using it. And we're going to use some jumper wires as usual. We're going to use a screwdriver for unscrewing and screwing. And we are going to use this very special thing aside from the School of IoT board, and it's a DHT sensor. So it's an DHT11 sensor, and it is used to measure the temperature or the humidity of your current environment. So it's a very useful thing. As usual, you can see the temperature using it, you can see the humidity using it. As its name suggests, it's a DHT11 sensor. So let's take our main thing here, the whole protagonist here, the School of IoT Development Board. So School of IoT Development Board, you know, it's great. I also love it. So we're going to continue with our connections, and luckily in this episode we don't need a breadboard, so we can just directly connect everything with the School of IoT. So let's start with our overview then. So you might be now thinking that, okay, I understood that there are a lot of things. We're going to turn our AC on and off, we're going to do that and that, we're going to do a lot of stuff, but why do we need to actually control our things using IoT? Well, let's say you're just being a lot more energy efficient using it, and also you're being, what is it called? Not stressing that much, because for example, you're outside, you turn your fan or AC, and you're just like, okay, I forgot that I turned my AC on and off. So you can just log in from your device and then turn it off. And also you can do another thing, as we're adding a temperature sensor to it. You can sense the temperature and kind of set your fan/AC according to it. So when it's too hot, your fan will turn on, and when it's too cold, your fan will turn off. So you're being a lot more energy efficient, you're being a lot more, what's it called? Kind of lazy, but yeah, everything comes down to ease of use anyways. So let's start with our connections. Let's start with our hardware setup. So first off, we're going to connect the jumper wires. So we are going to connect these things. We're going to connect the jumper wires to our sensor. So let's connect it. There are 3 pins here, as you can see, VCC, data, and ground, GND. So we're going to connect our VCC with red, as the creation goes. Positive is always red and negative is black. So let's connect this. The white one is for data, and what the data pin does is it sends the sensors as you can understand, data to our School of IoT board, so we can see the temperature and such. So let's already this connection is done. We're going to connect our motor. Now what we're going to do is we're going to take our motor and we're going to connect it as an extender, so we can just connect it directly here. Now we're done with that. Let's start with our connections. Let's see our code here, what our code says. Okay, so alright, so our sensor is connected with IO pin 13, and our this fan is connected with pin number 2. I suppose it's connected with IoT-27. So how do you understand what's the IoT-27 and 26 of this release? So here you can see beside this LED there is IoT-27 and beside this LED there is IoT-26. So it's pretty easy to understand. And in our code we are going to connect our sensor first. So let's connect our VCC with 5 volts. You can even use 3.3 volts because it kind of doesn't matter for this sensor. But there are some sensors which will burn out when you use 5 volts. So you need to be careful on that. And we're going to connect our ground. Alright. And also now we're going to connect our, what is it called? We're going to connect our data pin with IO pin number 13. So our sensor is connected. Yep, that's all there is to connect it. And now we're going to connect our DC motor. So as usual, we're going to unscrew this relay, connect our common pin, right. Our pin is connected. Now we're going to connect it with 5 volts. Alright. Now we're going to connect our one. So DC motors don't have polarity. Alright. So it actually depends on which direction they rotate in. It's basically like clockwise or counterclockwise. So it actually depends on the way you're starting it. Other than that, this motor doesn't have any polarity. So we're just going to connect this LED with our ground and connect our NO pin, which stands for okay, let's start. Which stands for NO pin actually stands for normally open. So it's actually normally open as the name suggests. It's pretty easy to understand. Okay, I'm doing a it's not relay 26, my bad. So it's we have connected our whole circuit. Our circuit is done, and yes, it was that much easy. So we're going to just let it here. Take our sensor and let it just rest. So it looks kind of good. We're going to just assemble it. So, yep, it's done. We have connected our sensors and everything else. Now let's move on to the software part and set this whole thing up. So let's start with it.
Alright, so here we are in the School of IoT dashboard, and now we're going to set this thing up and see if it works. So let's go to equipments, and then we're going to add an equipment. We're going to name it fan control. Alright. Let's give it a description. Well, we can it's totally optional. You can either give a description or not, but I'm just giving it for giving it. So let's name it School of IoT Project 2. So we're going to add an icon. Let's add this icon, and then we're going to add some actions. So let's add so let's check our code and see how many actions we need. Alright, so we need 3 actions. So I've added 3 actions. Now we're going to add a trigger. Alright, so what trigger does is it triggers the fan to be turned on when it senses that temperature, whether it's too warm side or it's too cold. So let's name this thing. We're going to name it, let's see. Now remember, we're going to name it exactly the same as the code. So we're going to go over here and name it auto mode. Alright, let's copy that and paste it here. Then we're going to also do manual mode. We're going to copy it and paste it here. Then we're going to do fan. Then we're going to select this boolean, default value 0. Alright, so here goes our setup. Now we're going to name our trigger. So let's go back to our code and see what's the trigger named. Alright, so it's named trigger temp. So we're going to copy this and paste it in here. Now remember to make it exactly the same as your code, otherwise it won't work for this project. And another thing is you need to name it exactly the same along with doing some slight changes. So for example, here is 3 actions and a trigger. So what it basically does is, in auto mode, when you will turn it on, that time the trigger is activated. So when this thing senses a certain temperature, that time it will automatically turn on the fan. But when it's in manual mode, that time you can just manually turn the fan on or off. So that's our equipment. We are going to save it, and then we're going to go to register equipment and find our equipment. So let's add these registers, name it fan control. Alright, so let's submit it, and here we have it. Well, another thing we need to do is, here's this token. We are going to copy this token and paste it in constant character after this equals sign. Now remember to paste this thing because it's the most crucial step. Otherwise, if you don't do that, your project won't work, your equipment or devices won't work. So after we have done this, we're just going to upload the code. We've uploaded it once, but we're going to upload it again just to show you. Then we're going to go to dashboard and bring out some switches. So we're going to add 3 switches, one for auto mode, one for turning on manual mode, one for turning on the fan, and one for reading the temperature. So it's a field value. We're going to take a field value, and now we're going to name it, let's say we're going to name it auto mode. Okay, slight mistake there. Our registry is fan control. We're going to select the action and it's auto mode. Now let's submit it. We're going to add another one and we're going to name it manual mode. Alright, so the registry is fan control, manual mode, and submit. We're going to do this thing here. Fan full. The registered place is for submit. We're going to add the trigger. So the registry, the trigger is temp, short form for temperature, and we're going to select 0. So Currently it's going to show 0 because the School of IoT is not turned on, but it will show the current data when it's turned on. So that's pretty much it. Our software is now set. We're just going to we're going to power our School of IoT board and see if everything works. So that's pretty much it.
Okay, we have set up our software and everything else. We have done setting up our dashboard. We have connected everything. We are now going to just see if it works. So let's see how it works. And well, we're not going to control this thing from our PC. We're just going to use our mobile device or our iPad to control it. Well, we have another mobile here, but I'm just going to use this. Big screen is always suitable. So as you can see that there is this temperature. We can already see our temperature value coming. So it's actually 21 degrees Celsius here, not Fahrenheit, just to be clear. So let's refresh this thing again. And now we are going to control our this DC motor. So in the software, in the setting up video, I have already told you what the auto mode and manual mode does. Now we're going to actually just test it out and see how it actually works. So let's start. So we're going to take our DC motor. Obviously we don't want it to be flying around. So we're going to switch to auto mode. And okay, so as you see that our temperature is 21 degrees Celsius, so we don't actually need an AC or something like that. We had 27 degrees Celsius set up in our code, so it's not going to work. So let's turn off auto mode as we don't need it, and let's set up our manual mode. So let's turn on manual mode. Okay, and here it is. So as you can see that our DC motor is spinning. It's working totally fine. We are controlling from our iPad, and obviously nobody controls their phone or AC from their PC except some people. So let's turn it off. Let's turn our fan off. Okay, we have turned it off, and let's see the temperature. Where is the temperature? So we're done seeing the temperature. Our fan is turned off. Let's turn off manual mode also. Now, if you actually want to know whether this temperature thing works or not, we can do one thing is we can, currently it's showing 21 degrees Celsius in my code. Alright, so in my serial value, it's written 21 degrees Celsius. We can change this whole value to 20 degrees Celsius, and then we can turn this whole thing automatically. Now, to get more detailed info about how this temperature sensor takes values and then writes in our code, and to see how we can change the values and everything, you can see our other series. It's actually School of IoT kind of coding part, the whole software part from the developer himself. So that's pretty much it. Our whole fan and AC control thing is done. Everything is being nice, and you can also see data from it, like the charts and pie graphs and everything else. So that pretty much concludes everything. I'm going to say on the next episode, in episode 3, where we will be doing something much better, something much unique. And until then, see you next time.